All right, so we have the focus tube and the nozzle taken off. This is supposed to be a cleaning mode for the SUP 23T. So what we're trying to do here is to see if we can use the Crossfire Pro and do some cleaning to take the mill scale off this. This is probably looks like 1/4 inch hot rolled steel. It's got a mill scale on it. We're gonna see if we can just take it off with the laser instead of having to clean it off with muriatic acid or something. So we're just doing some experiments. So right now I have a pattern on fire control. I just generated a straight cut, and then I pattern it, and the pattern is 0.3 inches. So what we have going on here is the laser width. We set the laser width to the highest it can go. It's set at 6 millimeters, and you can kind of see that I can go up and down. And I can change that. And we measured this. We measured this to be about 3/8 of an inch wide. So what we're going to do is run this pattern, and we're going to run, I don't know, a few lines, tried some different settings. So we'll read out what the settings are that we're doing here. Let me move this over here a minute. Get this in a little different position here. All right, let's try that. Okay, so now make sure we're focused. Okay, where are we at?
2,000 millimeters per second scan speed.
Sorry, this is our scan speed, so that's what this rate is. I'll slow it back down to what it was.
Yeah, that's what it was.
The 2,000.
We were 9,000. We just tested.
When we did the slow zip.
Oh, that was 1,000 or 500.
Yeah, put it back to 500. Okay, so I'm going to come over here and put my 0 point in right here. We'll go ahead and zero their axis. And what are you at now?
500 millimeters per second, 500 watts.
So we're at 500 millimeters per second, which is this scan speed back and forth. And then we say how many watts?
500.
500 watts. And I'm running fire control at 120 inches per minute. Okay, so I'm just going to run a couple beats here. You got your glasses on?
Yep.
All right, so if you look at this thing, you kind of see this has got a zigzag pattern on it. So it's doing something, and this metal it's a little bit warm down here, but it's just not cleaning. So we have several options here. We can change the scan speed, we can change the feed rate, we could change the laser power, and we can change the Z height. So we're just going to keep going with it. All right, let me get this back in there. So go about it right there. Make sure we're focused on something. Okay, come back in here, set our 0. All right, what are we doing now?
What do you want to do? Focus or?
No, I don't want to do focus. Let's change the scan speed.
Okay. 2.
What are you up? You're going to 2,000?
There you want.
Just tell me what you're doing. We're just fooling around, so it's fine.
Okay, go to 2,000.
All right, we're going to 2,000 hertz on the scan speed. The last one was what?
500.
500. So this is 2,000. We're at 0. Okay, here we go. Okay, so it comes over here and it starts to fires up the laser, and this actually got pretty clean over here. The reason why it starts the laser and then it waits a little bit and moves is that I have the pierce delay set to half a second. All right, and that looks like it's getting pretty clean there. There's like a little ridge there. That's actually kind of a funky pattern. That almost feels like it's sandblasting.
Yeah. Maybe go slower on the.
I think I should go I think I should go slower on the speed.
Yeah.
All right.
Feed right over.
Yeah, so we'll change the feed override down to 50%. So we should be at 160 or 60 inches per minute. Go ahead and set our zero again. Okay, we'll do a couple passes again. You might have noticed that it did the third line, but the laser wasn't on. I took my foot off the safety pedal. Okay. So let's look at this again right here. So it looks like it's getting cleaned up on these edges up here, but not in the center.
Faster scan.
Let's try a faster scan at that speed.
4,000. Double it.
Yeah, we'll double it. So we're going to 4,000. Was it 4,000 millimeters per second?
Yep.
You know, we got so many units going on here. Okay. So get that down like that. Make sure we're focused over here. Okay, so we're going to be at 60 inches per minute. Scan speed is 4,000 millimeters per second. Zero that. This. Glasses on. That's not the right speed.
Yeah. One override again.
All right. Okay. So fire control has this annoying behavior where if you stop it and hit the reset button, it resets the feed override. So yeah, I hate that thing. I've been burned a lot on that kind of problem. Okay, so we got the feed override set at 50. So we're doing 60 inches per minute this way. Scan speed is 4,000 millimeters.
You want to change the pierce delay to 0 or you want to make it?
No. We just leave that. That's another variable we don't need to change.
Right.
All right, next, here we go. Okay, let's take a look at this. It looks like it's doing. Ow, this is getting a little bit warm.
It's pretty clean and shiny on the top.
It's looking good, and it's looking clean up here and looking down there. So it's spending more time up here because it goes back and forth. What can you change the speed on the scan speed up to? What's the maximum on that one? No, that's not what we want to do. I think we might have to slow down everything. Let's slow the feed rate down to 25%. Can we go to
variables?
Yeah, let's just do the same thing. Probably should be writing all these down, but we're not gonna. We're just playing around today, so it doesn't matter. All right, so that's our 0. Our feed rate. We're gonna change our feed rate down to. We'll go to 10%, so that's going to be 12 inches per minute. I guess. I don't know.
Put some heat into it.
That's going to make it hot. Okay, here we go. You're going to need to turn the fan on for this guy.
Yeah. That's right. It's pretty good though.
Okay. Touch that one. I don't know. I think I melted.
Yeah.
You kind of melted the metal on that one. I think we're engraving at this point. This one looks like we're engraving now. Yikes. That's a steamer. I don't think that's good. I don't know.
Power down maybe a little bit.
What do you got power wise?
500.
500. Let me change the feed rate. Let me make the feed rate 3 times what it was. So we're going to be 30%. Be 30% of 100. So it's about 40 inches. 40 inches per minute. We're at 500 watts and our scan speed was 6,000.
Yep. 4,000.
All right, so scan speed's 4,000. This is 40 inches per minute and 500 watts. Try one more time here. Make sure we're kind of in focus here. All right, glasses on. Get this out of the way. I need that nasty shadow in here. I don't know. What do you think?
Shiny top and bottom.
Yeah.
It's weird. I don't know why it would do that. Unless it was pausing.
Let's move the Z height. Let's do the same thing, but we'll move the Z height down.
Okay. I like it.
All right, so we're going to come back over here. So we got the Z height set. We got the Z height set to maximum right now.
In fact, in focus would be 60 millimeters away, right? Which is a 1/4 inch. So if you actually moved it down and got the beam width to a 1/4 inch on focus.
Hold on.
Yeah, you can see it.
You want that 6?
1/4 inch.
1/4 inch. That's pretty good.
Yeah.
That's pretty good. Okay, so that's a 1/4 inch.
Should be about 6 millimeters wide.
So I'll make our Z over here. We'll make sure we're focused over here. Okay, let's read off the numbers again. So we are at 30% of 120 for our feed rate.
4,000 millimeters per second scan speed, 6 millimeters in width, 500 watts.
500 watts. Here we go. All right. Well, that's interesting, isn't it?
Yeah, it is.
That looks pretty good.
It does.
Man, that got kind of warm. This whole thing is getting warm.
Yeah. Throw it in the microscope.
Does your microscope record?
Yeah.
You put an SD card in it?
Yep.
Okay. All right, we're gonna put this under the microscope. We'll take a look at what this last one does here. All right, so we'll start at 500 millimeters per second, 500 watts. All of them are at 500 watts and 120 inches per minute. Just get this focused in here. So we'll move over here and we'll show you that you kind of see zigzagging back and forth. So the laser, it was defocused at this point. So the focus point's actually the dot is actually pretty wide at this point. It's moving back and forth. Okay, so, and it's moving fairly slowly also. Yeah, having some problems focusing it. Okay, there you go. There you got a good image of it. So this is actually moving back and forth a lot faster. Same travel speed. So I don't know what to make about all this differences. This one's 2,000 millimeters per second. That one was 120 inches. This one's 60 inches. So it's not moving as fast. So it does look a little bit different. Let's go ahead and zoom in here. I'll kind of show you some interesting things about this. So it looks like it's melting the metal, but it's pooling at different spots. I don't know if this has to do with the way that the fiber laser um, generates up its power and does all that switching back and forth of the individual fiber laser modules inside the fiber laser itself. So that's 60 inches per minute. This was 4,000, so we're going back and forth faster at 120 inches per minute. Kind of see something very similar. Okay, so let's move up. We're slowing down now, but our scan speed's pretty fast. So this was 120. This one was 60. So we'll move up to this one. Now this one was the one that was really slow, 4,000 back and forth and 12 inches per minute. So this is really slow travel speed. So I'll go ahead and zoom in on this. You can kind of see the detail you can see the streaks going back and forth at this speed. Let me see. Okay, I'm on this one here. So, all right, so we're going to go focus in. And you can kind of see that there's a lot of motion here. Very fine streaks. This one up here is a little bit faster. This one's 12 inches per minute. This one's 40 inches per minute. Same back and forth, but you can kind of see that it looks like the surface dots are like accumulate and maybe they suck together. This might lead to giving us a little bit better indication of their dross. So this is where we move the laser down and we got it focused in. So it was defocused on all the other shots. This one's actually fairly focused in. And you can kind of see that it's even finer in terms of the lines itself. Because that's understandable because the laser is actually focused. So the dot is actually a lot smaller on the metal at this time. But I don't know what's going on with those two mountain ridges kind of in the center. These ones got these globules, okay, and these ones have something else going on in the middle. This might be surface contamination or the mill scale or whatever, but I don't know. Interesting results though. Maybe this will lead to our better dross elimination. We'll have to see. All right. Well, today's experiment was pretty good, I guess. So I'm going to do one more thing here. You got to see what this looked like under the microscope, and so what I want to do is I'm going to take a flappy disk, and I'm going to knock this amount off here, and kind of come over here and see how much it actually cleans off of this. This actually does have a texture to it. So we'll go ahead and take a flappy disk of some of these, and we'll see what it looks like with when I take off the mill scale on the end. All right, here it is with the mill scale removed. Let me focus in on this guy, if I can. All right, so you can kind of see right up in here, it looks like we actually engraved into the metal on the edges of our scan lines. Down here, it's not so pronounced. This one right here is not, it didn't engrave it, okay? But there's still a texture here, so it kind of pitted it. So the laser is actually doing a little bit of engraving on that right there. And then the floppy disk came over all the way over to here. So this has still got a little rough texture to it, but this is smooth. So I don't know if this is a valid way of actually cleaning off the mill scale, but it does provide some interesting characteristics that we might find an application for. Particularly this one right here. This one actually does, it looks pretty good. We'll have to try something here. Okay. Let me get something set up, and we'll show you something here in a minute. Okay, so I think we're done. I think this is kind of a bust for today for cleaning up the mill scale, particularly for what I wanted to do today. But I'm going to leave you with a little note. So glasses on, or what are our settings?
4,000 millimeters per second, 6 millimeters wide, 500 watts.
Okay, and we're running at, I think it's 30 inches per minute. So here we go. All right, there we go. See if you can see this here. Let's see. So take this camera off here. All right, there we go. Thanks for watching.